All right, it is 11 a.m. I'd like to welcome you to our second Advanced Kentucky online content review session for AP Computer Science A. My name is Aaron Timmons. I'm the Mathematics Content Director for Advanced Kentucky. I'm joined by Dr. Sherry McGuffin. She's our STEM coordinator, and our presenter for today, Mel Hoffert from Sycamore High School in Ohio. Just a couple of housekeeping things to go over, and then we will go ahead and get started. So just a general disclaimer, we were very fortunate to have students from across the country join us last week. So again, these sessions were designed for a Kentucky audience. We wanted to support Kentucky students and teachers during the COVID-19 event. However, space permitting, we do welcome students from all other areas, so please feel free to invite others. We do ask that we keep our behavior appropriate, so any participant causing a disruption will be removed. The contact information and Twitter handles, Facebook handles for all of us can be found on this screen. Please feel free to reach out to us with any follow-up questions about how we can improve the experience or any other questions you may have. Your microphones for this session will be muted and the videos will be turned off. We ask that you leave your videos off for the entire time. Please utilize the chat box at the bottom right-hand corner of your screen. That is how all of our conversations will take place. You can chat directly with any of the hosts. You can post questions to the entire group as well. Please make sure you also click the join audio button in the bottom left-hand corner of your screen so that you can hear what we're saying. Please check out our kyap2020.com website if you've not done so already. This is where all recordings of our sessions will be posted, as well as other resources for both students and teachers. You can also see upcoming events for all subject areas. And finally, we're going to take about 3 minutes here. If I can ask that you all open up a new browser and go to this link to sign in for us, we'd like to just keep track of who all is watching and participating so we can share that and information with you. So I'm going to pause the recording here for about 3 minutes, take some time, sign in. It's a very quick 4 or 5 question Google form. All right, hopefully you've had enough time to sign in. Again, please make sure you are utilizing the chat feature. Any questions, regardless if you are a teacher or a student, feel free to pose those to us. I'm going to go ahead and stop sharing my screen and turn things over to Mel, who will introduce himself and then take it from there. So there you go, Mel.
Hi, welcome everyone. Happy Monday to you. Hope you had a good Easter weekend, Passover weekend, some time to spend with family, and you're rested and relaxed and ready for our session today. I am Mel Hoffert. I'm from Cincinnati, Ohio, and I've been teaching AP Computer Science in the Cincinnati area for, well, it's more than 20 years now. And prior to that, I worked in the software industry for a number of years. Most of the years that I've been teaching, I've had a longstanding relationship with the College Board and College Board consultant and a table leader for A and for principals. And so for today, the topic that we're covering is a Computer Science A topic related to writing classes, designing classes, and predicated on the notion of being able to design and write classes is the whole notion of understanding then the anatomy of a class. So we're going to begin with that whole notion of a class. What is a class? What are the various components of a class? And then work our way into how do we take then the fundamental concepts of class, the anatomy of a class, I guess we could say, and apply it to designing, writing classes in the context of a free response type questions from the College Board. So I'm going to share my screen with you. You should have received a document that looks like this. So here we go, I'll share. This will be our starting point for our session today, is this document. This handout provided to us by good friends at NIMSY. And it will lay the foundation, and then we'll work our way, as time allows, we'll work our way into examples, increasing a level of complexity as it relates to class design and writing classes. But we're going to start then with just some fundamental object-oriented programming concepts as it relates to classes. Okay, so we have these bullet items just as a reminder about what classes are all about, and then we're going to do a couple of scaffolding type exercises that will check your understanding about these bulleted concepts that we see here. So you see in the list on the first page of your handout, this whole notion that a class is just, if you're thinking about it metaphorically, it's like a blueprint. If it helps you to think about blueprint from an architectural standpoint, then that might not be a bad way to go. Just as architects' blueprints do not, by having the blueprints in hand, does not give you the building itself, in the same way, by having a class in hand does not give you an object that you can actually use in your program. So a class is just a design aspect, we could think of it that way, a preliminary step ahead of actually creating objects that then we could use, that we can instantiate in our program and utilize then in our code. So it's good to keep that whole blueprint idea in mind, because sometimes students misunderstand that notion, and maybe you have in some of your coding that you think by the fact that you have a class definition that all of a sudden objects now are available, and they're not. What does a class do? It encapsulates then the attributes and also the behaviors of objects that then potentially will be instantiated. So we need to be able to keep track of the object state, but also we need to provide behaviors, and the behaviors will come in the form of methods. And then we need to think of a class definition as a data type. So we can instantiate then objects of this type, of this class, but we can also include that class in maybe other class definitions. That class, objects of that class can then become members then of another class. We have a thing called composition that will allow us to do that. What we think of it like another data type. Just like we have primitive data types, then we can have these more complex data types that have attributes and behaviors built into them. By the way of anatomy of a class, now on the second bullet item, you have the class header. That's the first line of the class definition that provides the name, and typically the word public, we would, for the most part, we're going to think, in fact, within the scope of the AP framework for computer science A, we're going to think of all of our classes as public classes. And in the header, then we provide a distinct name that adheres to the guidelines for identifiers. Within our class definition, then we have instance variables. Now, what you need to think in terms of private instance variables for those particular members of the class. In fact, the College Board has really, the past several years, for the free response questions that they've given to students, the expectation is that all of your instance variables, those are variables that are contained in the class that help maintain the state of the object. All of those instance variables are expected to be private. We also have constructors. Those are special methods that are invoked when we instantiate then an object of a particular class. And then we have other methods that we'll discuss, accessors, mutators as well. Private instance variables. Again, the College Board is expecting then all your instance variables to be private. we have the constructor, and then we have other methods that represent the behaviors of an object. We talked about public and private. Those are the only two access levels that the College Board expects you to know. There is another called protected, but it's outside the scope of Computer Science A. So public and private are the only two that we'll consider. We do have this whole notion of static methods, and we're going to see an example of this in some of the scaffolding exercises, and then also some of the free response that we'll consider. When you have a member that is static, what that means is then you have access to it without having to instantiate, without having to use the new operator on that class. You can then, you have access to those members directly through the class name. And the most common example is the math class that's given to us by Java. You can access those members without having to construct a math object. You just provide the name of the class, and then whatever member, static member, then that happens to be a part of that class. In order to instantiate a class, in other words, create an object of a particular class, you see then on that bullet item where we have dog Frank equals new dog, there we're taking this class that's been defined, we're instantiating it, creating a dog object, and then we're using the dog constructor on the right-hand side, which happens to have two parameters, provides some string information and some numeric information. Then after we instantiate it, then we can just invoke the various methods that are made public within that class definition through that object name, in this case, Frank. You can have multiple constructors, and you do that by what's called overloading. And the magic behind that is that Java, the way it determines the name for a method is based on the name of the method and its list of parameters. So as long as you have a distinct name and set of parameters associated with a method, then from a Java standpoint, that method is considered distinct. So the way that we overload a constructor is, and you see then the possible ways we could change the number, the type, the order of the parameters. And there then we have what's called an overloaded method, in this case, an overloaded constructor. Same sort of thing for any, that applies really to any method within our class. And then accessor methods, they allow then, the person that is using a particular object of a certain class to have access to those privately held instance variables. And the College Board will, and you'll see this in some of the free response that we take a look at. And even if you don't see it explicitly stated, you need to think about all your instance variables as being private. And then the way that then access is given to those instance variables is through accessor methods. Accessor methods, they allow information to be returned about the state of an object, but no change happens to the state. It just simply returns information. We also have mutator methods. Could change, but doesn't necessarily have to, but could potentially change the state of the object. And by changing the state, what we're saying is that any of those privately held instance variables might be altered by a mutator method. So you see, by privately holding our instance variables and then very carefully controlling how the state of the object is changing, we can then maintain the integrity of the object. That's the key behind this, is being able to assure an object's integrity. We also have a toString method that's inherited from the Adam and Eve of all objects, capital O object is a class. All classes inherit from capital O object. And by virtue of the fact that it inherits from this class, there is a toString method that's built in to each and every class, whether you like it or not. And if you don't override then that toString method to return information that's particular to whatever class that you've designed, then the toString method is going to return hash code, gobbledygook type of information that you somehow uniquely identifies then that object. But you do have the permission and the ability to be able to override then the toString method to customize it to the particular class that you are defining. Any questions about the overview of classes? I wanted to just take a quick run through that before we dive into our first scaffolding exercise.
Mel, I was just going to create a word wall. There's lots of vocabulary that goes with classes, and I'm just going to put that in the chat box just to let participants know.
Awesome. Thank you. Appreciate that. Okay. So here's our first exercise. And how many do we have in the room? Let me see here. We've got, looks like 8 in the room. Is that right? Okay. We're going to try this first exercise. Exercise 1. We have these various terms for which I gave you the overview. And we want to identify then, within the context of this class called dog, we want to identify the various members that are contained in this particular class definition. Okay, so what we're going to do on this, I'm going to invite you to join then a breakout room. It'll allow you in a smaller group setting to discuss amongst yourselves how you're going to label then the different members of this dog class. And then I'll just float between the rooms and just kind of see how you guys are doing. And then after a few minutes of that, then we'll rejoin the main room and see what you guys have discovered. Okay, so look for, go to, let's see here, under more. Can I get to my breakout rooms? Here we go. Okay.
And then Mel, if you can just make sure that Sherry and myself are in the, I don't know how many rooms you're going to create, but if you just make sure one of us is in each of those, we will continue to monitor.
Yeah, two breakout rooms. Aaron, I've got you in breakout room 1, Sherry in room 2. And then I'm just going to divide. It looks like I've got 4 others. And I have no idea. Well, I do have an idea about 2 of the names. I'm not sure. So maybe I don't know if they're students or not. Okay, so I'm going to, you guys look for an invitation to go to a breakout room. And
all right, you're good.
okay. Good job of sharing in your breakout rooms. Remember the goal for this scaffolding exercise was to take then these terms, these concepts that we discussed about the anatomy of a class and apply them to this class called dog. So how does that break out? What does that look like as far as constructors, loaded instance variables and the like? So check your, let me scroll down. I thought it was actually right. There we go. Okay. So then check the work that you did and make a note of it, and then we can do a quick debrief on this. The very first line of this class definition is called the class heading. We have 2 instance variables. They're both private, and keep that in mind from the College Board perspective. Make all your instance variables private. We do have a constructor that has 2 parameters. How do we know it's constructor? Well, it has no return type. It just says public dog. There's no return type, not even a void there. And the name of that method is the same name as the class. We have an accessor method. How do we know that it's accessor? Because it's just simply returning then instance variables that are, in this case, happen to be privately held. And what's interesting about accessor methods, you often get an indication that they're accessor because the return type matches one of the data types of one of the private instance variables. So for get name, we're returning then the name, and similar for age. And then of course the data type matches. We have an example of a mutator method. Sometimes, maybe we could say often, mutator methods are void. Typically don't return information, but that's not, we can't say with certainty that's always the case. But often mutator methods are void. And the expectation is, or the potential, we'll say, for mutator methods is that some change is being made to the state of the object. What that means is one of the instance variables is being altered in some way. And in this case, age. 1 is being added to age in a very controlled way. And often you'll see in your mutator methods, as they get more and more involved, there can be integrity checks that are actually occurring there. For example, we could do a check just to make sure that age has not gone beyond a certain number range. We would not expect a negative age value. And maybe the mutator called make older could do that kind of integrity check. Then we see the toString method that's inherited from the capital O object class. And here we are customizing then the information, distinct information is being returned for a dog object. We're going to take the name and the age, and then we're going to return that using the toString. Any questions about this, about exercise 1? Labeling then the different parts of a class. Okay. We now have exercise 2. We're going to consider then a different class called Candy Bar that has some instance variables. It has a variety of methods. And here you're just going to fill in the blank. Now, did any of you, maybe we can do this, do we have a hand raise feature?
We can do, we have voting buttons. We have like yes, no buttons if that helps, or people can raise hand, I think.
Okay, they can, okay.
Either that or they can type responses in the chat box too.
Okay. So did any of you move on to exercise 2, or maybe where you've completed exercise 2? Any of you overachievers, did you go beyond exercise 1? And what's the best way? Maybe they can just chat you, or they'll chat me. How will that work there?
I'm monitoring the chat box, so I'll let you know if there's anything that comes up.
Okay, cool. Maybe let's do this. If any of you went ahead and did exercise 2, just let me know.
I know Jeremy and I got started on it in room 2. We just didn't get finished with it. We spent a lot of time on the first one and then got started on the second.
Okay. In room 1, how about anybody want to report from room 1? What? Probably, maybe not in room 1. Okay. Do we do this, Aaron, maybe as another breakout exercise?
We can attempt.
We can make an attempt to do that. Okay.
Sure.
Okay, cool. All right, let me do this. I'm going to give you guys an invitation to a breakout room, and then you guys discuss then. So let me share the screen here. So the objective when we went to our breakout rooms was to consider this class called Candy Bar. And instead of labeling the anatomy of this class, instead we have a set of questions that check our understanding about then what we see here with regard to instance variables and the different types of methods that are there. So here's what we have by way of the key for this. We have, in the case of the first question, so by you looking at your document, then you can put these answers in context. We have 3 private instance variables that are listed in the class, 2 constructors. So we have what's called a default constructor, and then we have an overloaded constructor in this class. The default constructor has no parameters. And then we are assigning then our instance variables, arbitrarily assigning default values. And when you are assigning arbitrary values, give it values that make sense for the instance variables that are contained in your class. We also have then 2 accessor methods as well as 2 mutator methods in this class. The accessor methods, how do we fairly easily identify them? Well, they have a return type that's matching return type of one of our instance variables. And often, and Kevin and I discussed this in our breakout room, often we'll use the whole getter, setter type of nomenclature, naming convention. So we'll use get, and then the name of the instance variable, get, the name of the instance variable. Often we'll use that naming convention for our accessor methods. And typically in the industry, that's a commonly accepted coding convention. Also, you notice that, and this is a throwback to maybe even a prior computer science class that you've taken, we're using Camel Notation for then the name of the methods. So we have the getters, 2 of them, or 2 accessors that are using the getter coding convention, one for the double price and one for the string name. And then we have 2 mutator methods. One is void and one is not. And so that's when I hedged a little bit when we were looking at exercise 1. Sometimes your mutators might have a return type. And it's important in case of make king, because the idea is then to upsize, we're talking about a candy bar now, to upsize the candy bar and then return as a courtesy to the person that has a candy bar object to return to them what that upsize price happens to be. But we also then have another mutator where we're just changing the price that's passed as a parameter then. Under what distinguishes the constructor or the constructors from the others, there's no return type. And also the name of the method is identical to the name of the class. Now notice in the case of the constructor, Camel Notation is not used. And that has to do with the coding convention that when you are naming your classes, you don't use then Camel Notation. You use instead the notation where for each word that's a part of that identifier, the first letter is uppercase. So that then you can easily identify in your code something that is a class identifier or something that's an object identifier. An object would have Camel Notation or camel case. A class would not.
What is that notation again?
Camel Notation. So with Camel Notation, the way that works is if you have multiple words in your identifier, the first letter in the first word is lowercase, and then subsequent first letter in subsequent words are uppercase, like humps on a camel. So for get price, lowercase g, uppercase p. Get name, lowercase g, uppercase n. However, for class names, we don't use camel notation. We instead would say for each word that's a part of that identifier, the first letter of each word is uppercase. And we use that whole uppercase idea so that we can easily read then the identifier. But we want to be able to distinguish objects from classes when we are just scanning or when we're just perusing code. So again, to our constructors, they have the same name as the class. They have no return type. List the different return types that we see. Well, we can say for our constructor, we have no return type. We have double, we have string, we have void. And I believe that covers it. And what is the default price for the candy bar, for a candy bar object? Now this really goes to your whole notion about default constructor versus the overloaded constructor. The default constructor is one that has no parameters. And we're going to arbitrarily assign it default values that make sense for the various instance variables that are there. And we want to know, in this case, price, and we have the default price of 99 cents. Any questions about A through G? Okay.
Mel, you've got about 5 minutes left.
Okay. So we can skip past the multiple choice questions that are here. We don't need to consider that. But there is a free response question that we could consider. And maybe I'll just, we'll discuss it briefly. And maybe I'll just do a real quick reveal on the answer key for this. Well, we have this class that's given to us called AP line. And we're given an overview about this, just a general description about this class. And then we're given some examples of objects of this class and how they might behave, and how maybe we could utilize that in some, or how we could then gain some utility then from objects of this particular class. We are shown the construction of objects of this class with the various parameters that could be passed to the constructors, and then methods that could be invoked, information that could be returned to us. And we were asked to then write the class. So what's interesting about this type of free response question, we are given then information, empirical information, and we are asked to reverse engineer, if you will, then this class based on the general description, based on constructing and invoking some of its methods. We are asked then to determine the class definition. And we are given some clues in here from this particular example, like our constructor, and we see it in the example that have 3 parameters. We must have a method called slope, and we're given some information about then what that should return, maybe how that should be structured. We are told that we can ignore things like overflow. We could gobble up a lot of time in defining this class, thinking about special cases and trying to account for them. In this particular example, we don't need to consider that information. And we are also, by way of general description, told that we need to maintain then and in order for to be able to define the line, we need to be able to maintain the coefficients as a part of the state of this particular class. So the A, B, and C then are integral part of the state of this thing called AP line. So we would think about those as being instance variables that are maintained in our AP line class. What might this look like then? We will go to the solution for this class. The canonical would suggest something like this, that we have then the three coefficients, or actually two coefficients, one constant, I guess we'll say. We're going to have a constructor given by the definition, even by the examples, we can empirically determine that we have a constructor that has three parameters. We're going to use then that parameter to set then our instance variables. And then we have these two, and we're going to call these, they're an interesting version of accessor methods, because information is being returned. Now they're different from the accessor methods that we saw in the previous examples, because they're not just simply getters in a rudimentary way, just simply returning the instance variables. They are taking the instance variables, performing a calculation, and then returning some information. So it's another layer on top of the, I guess, the most rudimentary kind of accessor that we might encounter. It now adds another layer where a calculation is being performed. And we see that in both cases. Even this, the is online, which is what's called a predicate method. A predicate method is a method that returns a true or a false value. We could even suggest that this is an accessor method as well. It's not modifying, it's not changing, mutating the state of the object at all, just returning some information, but it's a layer above just simply returning an instance variable. In this particular case, it happens to be returning a Boolean, so we can say it's a predicate method, but it's also an accessor method that then is telling us whether or not for a given X and Y, whether that ordered pair happens to satisfy the equation for our line. In other words, whether that point lies on the line. And then that's the solution for the AP line class. I do have, and we didn't get a chance to cover it today, but you have it in your distributed materials. There is a free response question that's book related. This is actually a variety of our version of a free response question that was given many years ago, and it's our own little twist on that. So you see it there, the free response question itself. If your teacher, and I'm assuming that there are some students in the room, but I don't know, if your teacher needs the answer key to this so that you can pursue this in earnest, then let me know. And then there's also another one, again, that comes to us from a previous exam year, another free response question. It is a class design where you are asked to write or design a class given certain criteria and then certain examples. The old Get Lean Fitness one. I think I read this one, and I'm trying to remember. This was maybe 6 or 7 years ago. It's been a while since I've seen this one. But again, it's one that we've pulled, and I don't believe we made any changes to this one that you see here. It's one exactly that the College Board used a few years ago. And again, if you need the canon and the rubric for this one, let me know and I can make that available to your teacher. So I think we're well beyond our time. Are there any last minute questions, issues that we need to discuss?
None in the chat box. Looks like people are good to go.
Okay.
All right,
Aaron, are you
Mel.
going to do a wrap with my email address so people can contact me if they have questions beyond this session?
Yeah, let me share that right now.
Okay.
So there you go. Again, thanks, Mel. You did a really good job. I know we had some kinks with the breakout rooms, but as you can tell, it's the first time for utilizing that feature. So I was really glad that we were able to use that today. So if you need to get in contact with myself, Dr. McGuffin, or Mel, all of our contact information is on the screen in front of you. Please make sure you sign in if you have not, as well as make sure you're checking out our website, KYAP 2020. This recording, along with all others, will be posted there. Next week, we're going to be joined by Dr. Joe Hoffert, who will be covering Unit 7, Array List. So you may recognize Mel. I don't know if you know Dr. Joe Hoffert or not, but
Yeah, we're kind of related.
yeah, okay. So if there's no other questions from anyone, I appreciate you all being here. Please make sure you're sharing this with any and all interested parties, and we look forward to seeing you next week.
Thanks, guys. Bye.